Yeah. Hi, I'm Wanik Cho from Seoul National University. And today I'm going to talk about the hate speech corpus construction we've done for the Korean language. We will look through how we collected the source corpus and annotated them, along with some examples we faced in the tagging process. And don't worry too much because all the hate expressions are translated into slightly more smooth English so that you won't face the raw format of those bad words. First, we focus on some aspects on hate speech, namely hate speech and hatred, and bad words and insulting, and discrimination and bias. In Korean and other languages, there are various projects undergoing in the name of abusive language detection or toxic word detection, and there is social argument on that such prevalent hate speech matters a lot in online or offline culture. However, there are some argues on what really is hate speech, or can some expressions be called as hate speech? That is on definition. And is hate speech really hateful? Thus, we looked more on the practice of Korean online, where finding and blinding malicious expressions in game or broadcasting chat. There, usual practice is detecting swear words and profanity terms in dictionary-based way, or defining the sentences that contain specific terms as hate speech. On the other hand, blinding posts or comments of YouTube, Facebook, or Twitter seems to base more on a trained detecting system. However, in Korean, there has been less study on human annotation of the hateful utterances. In the literature of other languages, Wassim and Hobby tagged English Twitter posts with around 10 or more characteristics that implied hate speech. Advanced from it in Davison et al., the discrepancy between the theoretical definition and real-world expressions of hate speech is mentioned, and it puts offensive label expressions between hate and non-hate to incorporate the gray area. In Sagnetti et al., hate speech towards Italian immigrants were investigated, and beyond hate speech, it detects if the post is offensive, aggressive, intensive, or has irony and sarcasm, or shows stereotype. Here, stereotype is investigated as a factor that can be a clue to discrimination. Here we raise two research questions. First, how is hate speech displayed in Korean online comments, and what bias and how much toxicity are in it? And second, what characteristics does the Korean hate speech corpus incorporate in view of the relationship between bias and toxicity? We explain how we proceeded this. As a source corpus, we collected comments from the most popular Korean entertainment news platform from 2018 to 2020, and finally selected 10,000 comments by sampling and filtering. For this, we prioritized the comments with many downvotes percentage to guarantee the amount of bad comments. Next, we formulated the problem by discussing with 1,000 of them, finding which factors make the comment hate speech. One is bias, that is, people with some characteristic may behave in some way. This differs from a simple judgment, and it contains prejudice or stereotype towards some people. The others are hate, insult, and offensive expressions, which are slightly different with each other, but comprise hostility, profanity terms, or other sarcastic or unethical expressions. We aggregate this as the toxicity factors. With bias and toxicity as two main factors of hate speech, we formulate the detection problem as a multi-label, multi-class classification. First, the bias is categorized as primarily a gender-related bias, since it is prevalent all over the source corpus and regards almost all of human beings. Other biases, such as on age or nationality, are aggregated as an other biases label. The other comments are classified as none, and we state this as a problem close to detection because the existence of bias is not necessarily influenced by its intensity. In contrast, the toxicity is closer to the problem of intensity or the amount of it. There is no clear boundary between the different degrees of toxicity. However, for the problem formulation, we classified them into three classes, namely severe hate or insult, not hateful but offensive or sarcastic expressions, and non-toxic ones. Here are the detailed guidelines for bias and toxicity. For bias, gender-related bias regards gender, sexual orientation, identity, or other gender-related ideas. And other biases regard age, region of origin, appearance, occupation, and so on. If both kinds of bias exist together in one comment, then it is annotated as a gender-related one since we considered it is more significant. For toxicity, the expressions of label hate considers the expressions that are hostile towards some group of people or the ones that can cause mental harm to the addressee or the target. Also, insults or sexual harassments are included, considering their harm to the target. The offensive comments, though they are not as harmful as hate comments, contain sarcastic, cynical, guessing, or inhuman expressions that may make the addressee or other readers offensive. And the annotation was conducted as below. Given a comment without context, the annotators tagged each attribute of bias and toxicity into three mentioned classes. Every comment was provided to three random annotators, and the total of 32 annotators participated in pilot and main tagging phase. A simple demographic is shown below. In the pilot tagging phase, we checked the worker that fit with our project. We human checked if their ethical standard is too far from the guideline, and if our feedback was reflected in their resubmission. Also, we automatically checked if enough taggings were done and if there are too frequent cases of skipping the annotation. And in the main crowdsourcing phase, we did not provide the annotators feedback for each tagging, but conducted the annotation with selected 8 workers from the pilot tagging phase. And after the whole annotation of 8,000 instances, we commonly checked for bias and toxicity for the instances that all 3 annotators differ. For those, the task managers decided to final label after adjudication. And for toxicity only, where the problem regards the intensity, we also had final decision after adjudication if there is only hate or non-label, because if there is only hate or non-label and no gray area, then there might have been some kind of misunderstanding of the comments also. They were discarded if the comment did not reach the final decision. The annotator agreement turned out to be around 0.7 for the binary case that searches the existence of gender-related bias, and around 0.5 for the ternary case. For hate, we had similar agreement, and the agreement for both bias and toxicity turned out to be moderate in overall. We split the data for the left utterances. For test, the outcome of the discussion of the authors were used to guarantee the fit with our provided guideline. For valid set, we used the data tagged in pilot tagging, which went through tagging review, reject, and accept phase. Then they roughly align with our guideline. For the train, we used the data tagged by crowd, which is not reviewed for the whole, but went through adjudication for some special cases above. Though I did not include the classification result in this slide, the overall classification performance with bird-based model is around 0.7 in F1 score. But since this is more on the analysis of this data set, we should add some comments for the regarding analysis. First, our data shows that toxic comments possess slightly larger portion than none, while for bias, positive samples are much less than non-biased ones. We have something to remark that this is the tendency combined to our data set. This may lead to that lots of toxic expressions are there in celebrity news domain. For this, since we sampled in the order of downvote, the overall portion does not necessarily reflect the toxicity of randomly chosen comments. Also, one may think higher portion of toxic comments are there compared to biased ones. However, biases are usually implicit and might not have been visible to the users. So this may have not been accurately reflected to upvotes and downvotes in which are reflecting the sampling phase. Beyond the portion, we saw that toxicity is observed in most text with gender-related or other biases. In contrast, toxic comments do not necessarily contain biases. We think that the intersection may regard discriminative terms, while the profanity terms or insults may have not been thought as a bias for the annotators. Deeper into the category of the bias, we saw about 1.4 times gender-related bias in hate label compared to other biases, while the portion of gender-related bias goes half of the other in offensive label. We deem that this may be largely influenced by our guideline that concerns a lot on gender factors, but seems to still suggest that the amount of toxicity and celebrity news domain matters a lot with gender-related contents. Here we have a draft answer for our research questions. First, what is displayed in Korean online comments as a hate speech or social bias and toxicity, while one regards the existence and the other regards intensity. More on Korean hate speech corpus, bias usually accompanies toxicity, but gender-related bias seems to accompany more toxic expressions. But for disclaimer, our findings are confined to celebrity news comment domain of Korean, so wider range of corpus and extended guideline is required for more comprehensive investigation of hate speech in various types of text. Yes, this is our conclusion. Discussions on hate speech have diverse viewpoints, and our construction of hate speech corpus in Korean links those to be useful in real-world hate speech detection. We observed bias and toxicity in Korean hate speech, where the gender-related factors are dominant in celebrity news comments. And our future work includes building up hate speech corpus for various domains of text, from formal to colloquial, to deal with the cases uncovered here. And thanks for the listening, and our dataset is currently publicly available online. And we have disputed as this Kaggle challenge to encourage the participation of NLP researchers. And for easier data importing, we've updated this as a new package to easily pip install them and upload for the experiment. And this is our talk. Then thank you for listening.